today we will be showing you guys the use of all the different knobs that we see for the machine. So we have three Nakamuras. They call it Nakamura Tome, but they are different models. So the one that we're looking at is the TMC 20 Roman number 2, and then I will show you the couple other models that we have, but they all are made by Nakamura Tome. Okay, so these are all CNC machines. They're lathe. All they do is basic turning OD, ID, drilling a hole, and two of the machines. And the third one has a live axis, so it could also machine some profile and cut faces. Okay, all right. So today's lesson is going to be about familiarizing all these knobs that we have here. Yeah, this is TMC 20. Now we have SC150 and then another one SC250. Okay, and all of them, these knobs right here, which helps you operate the machine, they're very similar. So on a lot of them, they are basically duplicated. On some of them, you might find a couple other extra that do certain kind. Start on this side. This is, all of them, they have written description of what they do, but that's not really enough. So we'll see them in an operation one by one and what they do and all that. So, but this is an emergency stop. What is an emergency stop? Well, that's when your machine is running and something very unusual, noisy here. So instead of trying to figure out what's going on, first press that emergency button and stop your machine. So that way, and then when you stop your machine will basically shut off everything. Like, the hydraulic system will go all the way to zero without bringing this guy. What you have to do is basically push it down, everything shuts off. With the exception of the motor in the back, everything shuts off. So to bring it back again, you just have to twist this will release itself. All right, so, but before we start turning on the machine, I would like to discuss this so that way, you could hear it very clearly in the video. Otherwise, if we turn on the machine, there will be another noise, so you won't be able to really recognize what's going on. All right, so we know now what an emergency button is for. It's basically to stop the machine whenever something unusual is going on, while you're running your parts, some really weird noise you hear, or something is clocking, doing some serious damage inside the machine, your emergency stop is to basically kill the machine right away. And as a machinist, that's pretty much your job, to make sure you don't hear something unusual. And if you do, you press that and you go get the person that knows about the machine. It could be an engineer or a production manager, whoever. Just talk to those people, they will take care of it. It's not your job to figure out what's going on, and especially when you have to press something in an emergency situation, you always have to ask for help from people higher up. Okay, and then there is two buttons over here. One is feed hold, and the other one is cycle start. Cycle start is for a CNC situation where your program is already downloaded, and all you have to do is your stock is ready, the machine is ready to run, so all you have to do is press this cycle start and the automatic program would start running. Now while I was running, all of a sudden maybe I want to do an emergency, like not an emergency, but a temporary stop. So there is an one over here, it's a feed hold. What does a feed hold do? As soon as I press that, my turret would stop moving. It would just it's a temporary stop. And it's like, somebody jumps in front of your car. You slam on your brake, person is okay, you didn't hit him, you didn't touch him, the guy gets, or the girl gets out of the way. So that was a temporary stop. So you just press again, cycle start, and you move forward, okay? So that's what a feed hold. It's not feeding into your machine, it just hold. It's like your turret is not moving, it just stops what it is, okay? And then cycle start will restart that. So we know emergency button, what it's used for. We know cycle start is basically to start your program, and field hold is nothing but a temporary hold. Similar to what I just described as an example, when someone ran in front of your car, you didn't hit him, you didn't touch him at all, nothing went wrong, so then you just continue to drive. So just, from a field hold, you press a cycle start, that will take it off the field hold. All right, and there is another one over here. It says Spindle Jack. That is for the spindle. The spindle is nothing but another piece of hardware that holds your stock. So that basically spins. So if you want to jog it, meaning just move slowly, you can press that, but you got to be on the right selection on here to be able to use the Spindle Jack. And there is another couple things here. One is tool setter, and this is a tool setter that helps you to set the tip of the tool. So it would tell you, I would set its position. So for all, this machine could load all the way up to 10 different tools. I could set each tool with the tool setter. So it's like a switch. It comes from the back. It's like a robotic arm would come out. And there is like a sensor. You touch them into X as well as Z axis, because this is a 2-axis machine. Then the tool tip its position will be defined. Certain values will be embedded into the machine under the geometry offset, and you don't have to do anything else. So this machine has a tool setter. A tool setter is nothing but a device that helps you establish the position of that tip that does the machining, okay? And then there is another one over here to the side of it, and that's work shift input, and then there is a toggle here that says work shift on and off. So what I do is, when I know where my part is, I have to turn this from an off position to an on position, and then bring one of the tools out of those 10. I only need to touch with one of them, touch my part, and when I'm on that position, I say, hey, work shift input, and as soon as I press that, a value will be entered, and based on that value, the rest of those 9 tools will know where the part is at, okay? So that's how you basically establish the position on the Z-axis where your part is located. So this is a really neat tool that helps you basically establish the Z0 position, or at least where your part is at, okay? And then as soon as you establish that, you have to turn off the change it to an off position, and now your machine knows where your part is at, okay? Not only one tool, but all 10 tools, they know exactly where the part is at. So there won't be any kind of collision, okay? And then we got three, I guess, buttons here. I call them buttons, but anyway, this is, as soon as I press it, it says FWD, that's forward for the spindle motion. And so over here it says spindle, then you have forward, spindle, spindle stop, and spindle reverse direction, okay? So those are the 3 knobs. This is green, that is red, and that is, here's me, another green. So this is the reverse movement of the spindle. This is a forward, and while the spindle is moving, you can press a stop and it will stop the spindle. If it's moving in a reverse direction, you press stop and it will stop the spindle. So these 3 are nothing but to move the spindle back forward or in the reverse direction, and the button in the middle is to stop the spindle, okay? Now I can have my spindle running, and I can control the speed of the spindle. See right here, the speed. It says over here all the way really high, and this is basically really, really low, 0. So that's the speed of the spindle, okay? There is other green, not green, but like, buttons over here that don't have anything on them. Those are optional. okay? I don't have them added into this machine because I don't need them. But this machine could be modified to add a tailstock. You can also have a door that's going to be open, closed, kind of like more of, you know, a control where, you know, your door, you need sometimes when you're working, it could be open, it could be closed, but it has to be closed. When your machine is running, it has to be closed at all times because you don't want a chip or a part or something coming out flying and hitting you, okay? So, but for that, if I added that option, if the door is open, then the machine won't run because it has to be closed first. So we don't have that automatic. It's kind of more of a safety thing, but we don't have that there. We don't have a tailstock. But anyway, I was just trying to explain what these black buttons are. They're not buttons. They're basically, you know, they're plugged with something black, like a rubber or a cord. They're plugged, meaning there is a hole in here, but, you know, it's just plugged because we don't have those options in the machine. All right, so we're all the way out here. Now, there is another one over here. Look like, you know, a knob. There is X-axis, Z-axis, C-axis, and B-axis. All right. This machine, I said, is only a 2-axis machine, so you have an X and a Z, nothing else. We don't have a C-axis, and we don't have a B-axis, okay? So we only switch between X and Z, that's it. So if this knob is like a C or B, it really doesn't matter. You just have to make sure it's either on X-axis or Z-axis, depending which axis you want to move. All right. And there is a big guy over here. We call this a handle. And this is what moves the turret or the axis. Okay. I can move in the X-axis or Z-axis, but make sure first which way do you want to move. If I want to move on the Z-axis, this has to be turned onto the Z-axis, and then there is a minus and there is a plus. When I go towards the minus, I'm going into the negative Z-axis. If I go to the positive, I'm going into the positive Z-axis. If I want to go in the X-axis, I have to switch this guy to the X-axis first. Now I'm moving into the negative X-axis, and then when I move clockwise, I'm moving into the positive X-axis. Okay, so for you to use this guy, we have to be under this. Again, this is another switch here. It's called mode. Which mode are you? Are you on the automatic mode or are you on the manual mode? So first, this guy is for the manual stuff. Manual. You want to work manually? This handle, you have to be on the manual mode. Or my manual mode has -1, -10, and -100. -1 is a movement of 1/10 at a time. For every click you hear on the handle, each click is 1/10. Well, if you want to move your turret, you know, up or down, you know, up or down is basically the X-axis, or sideways, which is the Z-axis. If this mode is at 1x, you're only moving 1/10. It's going to take you days to move that thing. So you better switch to like 100x. That is about like, you know, 10,000. Now at 10,000, you could easily see and you could move to whatever location a lot faster, okay? So this is basically what we have. The mode is manual, or it could be on the automatic side. Whenever I'm running a program which is an automatic mode, I have to be on the automatic side. So it has to be under MEM, or it has to be under edit if I want to modify the program, okay? So I remember this is very, very important, you know, switch, because you could be on the manual mode and you're thinking to run your machine, it won't run. So you have to be on the automatic mode under MEM. If you're ready with the program, the minute you say cycle start, it will run. But if I am over here and I say cycle start, my program is ready, it won't run. Why? Because you're on the manual mode. So make sure that your machine is on the manual. Not only that, even on the manual mode, there is a handle, there is a jog, there is rapid, and there is a 0 position. whenever I want to return that turret to its home position, I go to zero return. Zero return is for the turret to go home. And then you press basically two of these buttons down, you press them, and they're going to go to zero position, and there will be lights here. But anyway, I'm going ahead of myself. So right now, we just want to make sure we understand this switch right here, which has two options. It could be either automatic or it could be manual, okay? So when I'm on a manual, there is a handle, there is a word handle written here, and there is times 1, times 10, times 100, times 1 is 1/10, times 10 is 1,000, times 100 is 10,000, okay? So if you want to move stuff a lot faster, you better be at 100x. That would mean about 10,000 for every click that you feel on the handle, okay? So these two, they work together. These two, they work together. If I'm on the automatic side and I try to move my handle or this knob right here, nothing moves. Why? Because I'm on the automatic mode. For me to work, I have to be on this handle mode, times 1, times 10, times 100. So usually I work under times 100, okay? Then I could go also to jog, and then I could press either of these buttons, then the machine will jog. It's not only going to jog the turret, but it could also jog the spindle. So for me to jog the spindle, I just have to press Spindle Jack. As soon as I press on that, the spindle will basically rotate out of control of the speed. I mean, at a relatively, slow speed. So I could increase the jogging, or I could slow it down with this knob right here, okay? So there is a lot of knobs, but as you get to, use the machine, you will familiarize yourself. They are kind of like self-explanatory. They have something written on them. So you kind of know what they do to some extent, but that comes with work experience. All right. Now there are 4 buttons over here where you press them down. And these, they also have a minus z-axis and a plus z-axis. So this movement on the machine is a minus z-axis goes to the left, to the right is a plus z-axis. Going up and down, up is plus x, and down is minus x. Remember, when you run a program, your values on your program, almost all of them, they are on the minus z-axis values. When you look at those numbers, they have a minus on them. Why? Because we're working on the second quadrant of the x and z axis, second quadrant, okay? And the second quadrant is nothing but all z values are negative, and x axis are positive, because you basically work on the second quadrant of the zx axis, okay? Good. So now we know what these are for. This helps you move the turret, moving home or moving up and down. And you do use these whenever your knob over here is at jog, or at rapid, or at home at zero position. You use these. But whenever you're on the 1x, 10x, and 100x, you use the handle, because look over here, it's written on it handle. So these 3, you could only use the handle to move the turret up and down or sideways, okay? But if I want to go a lot faster, I could go to 0 home, and then when I press these 2, remember my turret is at where? Its home position is always x is 0 and z is 0, okay? We'll turn on the machine and we'll see all those. But anyway, so you use these to move the turret to its home position, or moving it rapidly to whatever position you want, or jog it to whatever position you want. So you use these in combination with these 4 knobs right here. Okay, now we're moving along. There is another over here that says Spindle Load. This is nothing but kind of like a reference for you. Whenever it's machining, if there is a needle here, if that needle moves past 50, This is like, you got 0, 50%, 100%, and on 150%, all the way there is 180%. I mean, there is no machine that's going to run at about 180%. By then, you're removing too much material, your insert will break. Okay? At 100%, that's also too much. Your insert is going to break, especially if you're removing a lot of material. And the only way this needle moves to 100% is because the load on the machine is too much. So it senses. This is kind of more of like a sensing for the load, that the machine is like, running, and there's something is opposing it. The only thing that is opposing the movement of the spindle is nothing but a friction between the tip of the insert, which is doing the machining, and your stock. So the stock is being held by the spindle. So whenever you have that friction, the spindle feels the load, and that load is sent out here, and this will sense it and will tell you at what percentage it's running, okay? Now, so that is nothing but kind of like a reference for you. It always should be less than 50%. If you want to run your machine safely, and you don't want to have things coming off or flying off the machine, you want to run it less than 50. And if you run it less than 50, things will be just relatively safe, okay? Now, I got a bunch of other knobs over here, which I typically don't really use, but you got to understand what they mean. So this guy right here is machine lock. I can lock the machine. There you go. The machine won't move anywhere because I have the machine locked, okay? So for these switches, you just have to pull them outward and go down. But these guys right here, it just, it's a toggle on and off, on and off, they're nothing. But this guy right here, you have to pull it first and then move it forward because there is like a lock and key. If you try to move it down without pulling it up, then you're going to break this toggle, okay? So you have to pull it up and then move it, and then pull it up and move it to the on position. But usually I leave this one on the off position. I don't want to lock the machine. Okay. So the second one is block delete. Let's say some of you on your program, you put a forward, I think a backward slash or forward slash, and you have this guy under on position. Your machine will skip that block. And a block is nothing but the different lines on your program is considered a block, okay? So that block does something in the machine. It could be, machining something, or it could be turning on the water, the coolant. It could be turning the spindle. I don't know. I don't have a program in front of me right now, but I will explain that to you when we're running programs. Okay, so this guy, I could have delete block, meaning I could delete a block within my program. So that's an option you have there, but I usually leave it off because if you have a block that you don't need, why do you have it in your program to begin with? But sometimes you do, okay? And I will explain those situations. But anyway, I typically don't run, deleting block. There is another one says dry run. This is basically to check your program, see if everything is running okay within the controller without giving an error. So I can have this on and press the machine, and it was going to go through the program, and if everything, the right code is there and all, everything will run smooth. But if it's not, then it will give me an error. All right, and then I have over here single block. Remember over here says block delete. Now I have single block. Remember, every block in your program does something. So the machine, if I have a say, hey, just go single block, it will just only move one block, and it will say, all right, I just finished that one block. You have to tell it, okay, go, cycle start. You have to press every time cycle start, you finish a block. Why? Because you had this single block on. And you reuse those. Why? Sometimes you want to know which each block is doing. Okay? So you turn this one on, and it just like, it will finish that block and it will just stop. And until you press cycle start, it won't go into the next block. All right. And then there is over here optional stop. Another toggle here is an optional stop. I can have it on or off. Optional stop. Let's say you're machining a part, and all of a sudden, in your turret and the spindle, they almost want to kill each other. Why? Because there is so many chips entangled there. Before they do something serious, after you run your first part, you find out that that's the condition that you have. So what you could do within your program, you could put an optional stop, which is M0, and then the machine would run, and then it will stop. Why? Because I had this guy on, because there is an M. As soon as it goes into the M0 block, it would just stop. Now we will give you a chance to open the door, use a plier or however. You don't want to use your bare hand because those chips, they're really, really sharp. They could cut your finger, okay? So just, use like a hook or something and just pull out all that, those chips out of the way. And then you just say cycle start, we'll go into the next block and life moves on, okay? But again, why do you have chips that are tangled into each other, Because you have your speed, your feed rate, your spindle speed incorrect. That's why you have, the chips tangling or, basically piling up there. Technically, when you have the correct nose radius of your tool, the speed of your spindle, and the feed rate, things should just break. They should be just like, flying off like tiny pieces. Okay, so those, there is little learning curve you got to go through, or sometimes you could just ask the manufacturer of that tool and tell them, hey, what's the feed rate I should use for this insert you're selling me? And they will tell you that value, put that, that's your feed rate, and your spindle speed, they can also tell you that. And you put those combination, you won't have any kind of tanglement, everything will run perfect, okay? So you don't have to know everything. Sometimes, the people that do make the insert will give you the appropriate values you could input in your machine, and life would be a lot smoother. If you're trying to figure it out on your own, you're gonna go and spend a few hours and maybe cut your finger, do stuff like that, and then eventually you're gonna figure it out. Or you could go online and read about that, and you could figure it out that way as well. So remember, everything is over the internet. Learn anything you wanted to know from the internet. This about these machines, you could go over the internet, see Nakamura, Tome, Google stuff, and there will be a lot of information about these machines, and look on YouTube, and that's how you learn these machines. At least that's how I learned them, okay? All right, I didn't go to school for this. I didn't get a bachelor's degree on this. This is basically stuff that I learned from online by observing and, coming here on the machine, playing around, and that was that. Okay, now, so we just finished this upper toggle up here, which each one of them does, and there is one over here that says rapid override, and this switch right here, you got low, 25% and 100%. Every time you are running, setting up your tools, or you're running your first spot, this switch better be on low. Why? Because if you have it at 100%, that turret is going to come going towards your spindle to machine something at a very, very high speed. So if you have some kind of error in your program, you're going to have a really, really nice collision, okay? And that could cause some serious damage to your machine. So always keep this guy at low. It's kind of like, testing the waters, you just want to figure out what's going on. You just don't want to, let's say you're a starter and all of a sudden you want to run at 100%, and then you're going to find some serious damage in your machine, especially if you have some errors on your program, okay? You could miss a minus, and all of a sudden, or you could put a minus on a value that should just have been positive, because usually for a turret, as soon as it gets close to your part, everything is positive. But let's say accidentally you put a negative. Oh, you want to go all the way in, and now your machine basically collides with your spindle or with your stock, and it could cause some serious damage. So to do that, to avoid that, always this rapid override, there is not zero, low, which is very slow, then 25%, and then you have 100%. So you start to set up all your first part, to just, do your first part, do it at slow. I might take you 10 minutes, but who cares, or it might take you 4 minutes. I would rather spend 4 minutes rather than ruining my machine, okay? So I start on the low, finish the first part, everything looks good, and then you can go to 25%, which is a lot faster. Oh, and if you're expert, go ahead, put it 100%, and the machine is going to run like crazy, okay? But typically, I personally put it at 25%. That's good enough. I got nowhere else to go. The machines are running themselves, and I'm not in a hurry, so it's always safe to run at 25%. But let's say you're in a hurry, you can go ahead, put it at 100%, and the machine will do its job as long as everything is programmed right, okay? So that is the override switch. And then there is another over here, feed rate override. This feed rate override, I put it at 100 all the time. But let's say if I want to slow it down, I could, but this overrides your program feed rate. See over here says feed rate override. So if you have program has a feed rate, let's say 5,000, but I slow this guy down, then it's going to go a lot slower than that, okay? But typically, I put it at 100, and then, I just make sure on my program I have the right feed rate, okay? But let's say if it's machining a lot faster for you, you can always slow this guy down. But this is for a feed rate. That's why it's called feed rate override, okay? And this is rapid override for the rapid movement of your, your turret. Movement of your turret, you could control it with this guy right here. So there are two, they look very identical, and each one of them does different function. All right, now we got something over here. It says coolant, manual, and then I can have it in the middle, which is off, and I can have it on automatic. Every time you're running your machine with a program, this guy has to be on automatic because there is already a parameter in your program that tells the machine, hey, turn on the coolant. So if it's under the automatic mode, the program will have its own block that would turn on the coolant. The coolant is nothing but kind of like a fluid that comes out of a tip and cools your tool as well as your stock. So that way they don't get too hot and wear out real quick or start some kind of fire too. All right, not a problem. So, but if you want to, run the coolant manual, you can run it on manual. And so I have to basically press, when I say manual, meaning everything here is the handle is, the mode is on manual. When I say the coolant is turned on, there will be water spitting from the tip of the coolant, and because I'm on manual, okay? But when I am on automatic, it has to be from the program. The program has a parameter that will tell it to basically start water, and it's called M8. M8 is turning on the coolant. M9 is turning off the coolant. All right. The reason I mentioned those two is because we're talking about automatic coolant off and on, okay? All right, and there is another one here, program check on. And I could have this guy and the program check on, and then I can check my program. And basically at the beginning of the program, I say start, and my program is just checking the program, nothing else. So the whole thing would go for in each block and go through the program if everything looks okay. If there is an error, it would tell you there is an error, okay? It could be a semicolon, or the dot could be like twice of them there. You could have some errors if you especially enter in your program manually. If you're a guy that uses your brain and basically create your program manually here, then there is a good chance you're going to put error. Like it could be a comma, it could be a point, it could be a decimal point, whatever, okay? So you could have the program check on, and you say start, and it will go through the program for you and find out if there is a human error or not. Otherwise, thanks to Mastercam, everything will be fine. You create your program there, and we'll put everything correct as long as you select the right parameters. You will be okay. And you can come over here and you say check the program. It will check it for you, and it won't find anything out, most likely, okay? So that is how you also check your program. Now, I think we're pretty much done with everything except these two knobs. This guy is a stroke release end. What people do sometimes is they move their turret home position while it's under rapid move. Under rapid movement, this is under rapid, and they press the plus X and ZX twice, and this guy moves really fast, and it goes beyond the 0 position or the home position. Okay. What they sometimes what happens is people, they put this switch on rapid. They thought they put it on 0 return. Accidentally, they put it on rapid, and they press the plus and the plus Z and plus X. And as soon as they press that, the machine, the turret runs fast and try to go home, but it will go beyond the home position. When that happens, your machine over here, machine alarm, will just basically come on. It will shut off your hydraulic system. Everything will go because the machine is under an alarm mode. You did something wrong. When you do something wrong like that, these machines are CNC. They are not forgiven. They will just go ahead and shut off stuff for you. And if you don't know a lot about the machine, you're going to figure out, like, what am I doing here? What's going on? So you could scratch your head, and, you know, the machine is stuck. You have to call a maintenance guy. Well, you don't have to if you know what these knobs do. So when that is the case, you press the stroke and release down, and you're going to hear the machine say clack. It will send a click. Now all you have to do is go to the 100x and move into the negative, not onto the positive, onto the negative, whichever axis is you violated, okay? The reason the machine was locked or went into emergency is why? Either you violated the position, 0 position for the x-axis and the z-axis, both of them, or it could just be one of them, okay? But for all I care is what? Just make sure you go whichever you look, because there is a display here of the value. You go to the right axis and use your handle and move your handle into the negative, and then you release this guy and the machine will be back live and will be out of the emergency situation. All right, so that is what we use this guy for. Now the last but not the least, very important, this is what we call indexing. Remember, this machine has 10, it could load up to 10 different tools, and the turret rotates, it selects which tool it's working with, okay? So this is how you basically select each tool. You press on this green button, which is the indexing, and as soon as you press it, you will hear the turret. The turret will switch, would rotate, and for every press, it's going to move the turret one tool at a time. So when you go to the right tool number, you basically stop. So this is what we call indexing. So that completes the lesson on which all these are. And there is another one over here with a screen on it, and there is a bunch of soft keys here. I mean, there are soft keys and also functional, some keys over here as well. This is not any different than your computer, okay? So, you know, you got letters, you got numbers, and there is also, you know, position. POS is position. PROG is program, offset settings. You got system, message, custom graph, alter, insert, cancel, shift, input, delete, help, reset. There is up and down movement, page up and down, and there is, like, you know, letters, and I'm sure we're going to learn how to use this some other time when we actually run in a pod or when we run in the machine. Right now, today's lesson was nothing but to kind of familiarize yourself with all these buttons that we have here. And so this is for TMC 20, Roman number 2, again a Nakamura Tome. And then we'll go into another, oh, my bad, there's one thing. See over here it says power. There is, as soon as you turn on the machine in the back, you turn on the switch, you have to come here, turn on, so that way your controller could be turned on. Because just turning the switch in the back of the machine, which will send the electrical thing into this machine and everything will start running. but your controller, which is Fanuc Series 18T, won't be up and running. So you have to turn on with this button right here. And if I want to turn off the machine, also I turn on my controller, I turn on with this key right here. And then, so the sequence of turning on and off the machine is nothing but you turn on when you come early in the morning, you turn on the switch in the back, and then you come over here, you turn on the power. That will bring the machine up and running. It will take maybe a couple of minutes or so for everything, maybe less than a minute, but anyway, to see. If there are errors, let's say your oil is low or your pressure hose is not hooked, the machine will go under an alarm mode and things won't run. So you just look around and see what's going on and you figure it out from there. But that's basically, so that's how you turn on your machine. To turn it off, you first have to turn off the controller. So you press the off button and then you go into the back of the machine, you turn off the brake in the back. And that will kill the machine. Now you're ready to go home. It's quitting time, okay? All right, so that completes the lesson on Nakamura Tome TMC 20 Roman number 2, to just familiarize yourself with all these knobs. And then we're gonna turn on the machine. But before we do that, we wanna go ahead and look to the other Nakamura Tome SC150, which is a 4-axis machine. We're gonna go ahead and just look for the same thing we just went over here. See if there is any difference between the two machines. So come with me. And this is Nakamura Tome SC150, another CNC machine. It's a 4-axis machine rather than a 2-axis. Now, the reason I brought you here is nothing but to make sure, see if this looks similar to the TMC, okay? The SC and the TMC. So the SC150 is a 4-axis machine. This guy right here, they're the same. Emergency button the same. You know, the feed hold and cyclists are the same. The handle is the same. Over here, handle select. You got X-axis, Z-axis, C-axis, B-axis, and a Y-axis. Remember, this machine I said is a 4-axis. So the spindle is, which is a C-axis, and the Y is an up and down movement, and that is a Y-axis. Not meaning up and down, meaning vertically in relation to the X and Z axis. So, so this is a 4-axis machine. All right. Now all these knobs, toggle, they look pretty much the same. And this guy, like manual speed set, is also the same. You have forward and reverse the same. You got another new button here. It's called Spindle C-axis because this has a C-axis. So there is a button added here, and there is also another toggle over here for milling, sub-spindle, and spindle. And these over here are also the same, but there are two that are added here, and they are called plus Y-axis and minus Y-axis. These two are the same like the TMC, not any different. These, they change the shape of it, and instead of being like round, this is kind of like, you know, facing you, and you can see basically the needle move as the machine is running. Over here, the indexing is identical. Well, these guys, they have a door interlock on and off. They already incorporate. So the machine, if I were to put this guy under on and I have this guy's door open and I try to start the machine won't start. Why? Because these are a door interlock. So there is a sensor that's going to basically tell the machine, hey, don't run. Why? Because the door is open. Okay? So you have to close the door. You have to close the door for the machine to start. If I wanted it off, I could switch it to an off position and run it. The door could be open or slightly open and I will still be okay. But for your safety, always, no exception, close the door and run the machine. All right, and then over here, rapid override, the same thing. Feed rate override, the same thing. And the mode over here, you got manual and automatic and manual. These are also the same thing. There is another one over here. I guess they changed the position. Spindle Overrite, which does basically the speed. And that's the speed of the spindle, okay? They have it 100% here. That's how I run it. Sub-spindle override is optional. We don't have that. But this machine can add a lot more on here. And not only that, because this machine has a tailstock that is over here, advance and retract coil. Coil is what? Coil is but nothing but the tailstock, okay? It's over here, it says tailstock. So it could move back and forth. There is other options here, we don't care. I know the screen looks slightly different over here, you know, but they're not any different. When you look at it overall, they're very, very, very similar, very similar. With a few additions, they're basically identical, okay? And this guy over here, they might have moved some of the buttons somewhere else, you know, instead of being here, they put them on the side. Other than that, you're gonna read the same thing on both machines. Now we have our third machine, which is, I guess that completes for this guy, SC150. We have another machine, SC250. All right, so we just finished the SC150, and this is SC250. Again, Nakamura Tome, they're all the same machines, the same maker. All right, but different, like, you know, model. So SC250, again, when you look here, which is basically what controls the machine, this is a 2-axis machine, and they're very, very identical to the TMC, but the look of it looks similar to the SC150. So this right here, you know, the emergency stop button, feed holds, cycle stop, off and on for the machine. On our TMC is located out here, but this guy, they brought it over here. It says power, and then, you know, you got forward, reverse, stop, and then also the manual speed, and this similar. So this guy right here, the display over here, looks very, very similar to the SC150, but this is SC250, and the machine has the capability of with a bar feed, okay? Other than that, this machine is a 2-axis machine, okay? It's just 2 axes. You got Z-axis and X-axis. That's it. So it only does turning OD, ID, drilling a hole in the center, and facing the face. That's pretty much it. It won't give you any kind of like complex shapes. Why? Because this is not a life-axis machine, or it doesn't have a C-axis or a Y-axis, okay? So I guess I just wanted to make sure that you guys, you know, whenever you learn one machine, you can run the other machines. Why? They're basically the same. And why are we really focusing here? Because this is what controls the machine. This is the different knobs, switches, or toggle, whatever you want to call them, are used to control the machine. So without knowing these, you cannot really run the machine, because you don't know what you're going to be doing if you don't know what each switch or toggle or, you know, knob does. Okay, so that's pretty much what we're planning to do today, and I think that completes the introduction of how to use all the keys. Please go over the video, look at it, listen, and then we're going to start the hands-on. So today maybe we'll go back to the TMC and turn on the machine, and we're going to start playing around with all the different knobs. Okay, thank you very much. Number 1, but before we could do that, we need to go home. The turret has to go home, so we go to 0, 0 return, and then I press plus X and plus Z at the same time. That's it. And both leads for the 0 return, the X axis and Z axis, they both came on because I indicated here I wanted to just go home. And if I go press position here, my X is at 0, 0. In fact, I'm going to press until, look, my machine. The machine says X is 0, 0, Z is 0, 0. But then you have an actual position and absolute position, okay? So the actual position is the relative position, but absolute is the exact position. Right now, we just want to make sure that our machine is at 0, 0, and that's what we see here. All right, so, but the values that you see on the screen, x 0, 0, but z is not 0. Why? Because that's the absolute value. We're not looking at the machine value, we're looking at the absolute value. All right, so that will help us for something else for the machining purposes for right now. Now, we're going to start on the upper left corner for the tool setter. So we're going to set one of our tool, it's 0 position. Tool setter. Now we're going to press that button and look what appears in the back of the machine. That is our tool setter coming out from wherever it was hidden, okay? Now, our tool number 1 is right here. So I need to move this mode to a 100x. I have to be on the z-axis, and then I try to get as close as possible, x-axis, and I go down. As soon as I line up, and I just have to move closer to the z-axis. I put a piece of paper in the back. Why? Because it would help me in contrast to see it very easily. I switched my handle to a 10x because I want to slow down. I don't want to collide the sensor. So this is switched to a 10. It was at 100x, but now it's at a 10. Why? Because I'm getting very close to my tool setter, okay? So I'm going to go ahead and just move this guy. And when I touch that sensor, there will be a light that would lit here. And also look the number on your screen. The number on your screen, because right now we're doing z-axis, it will try to change. But if we had it set up right, we might not change as much, okay? But let's go ahead and touch that tool setter and see what happens. And I'm waiting. The light is already on. And look, this guy at minus 5.051. It changed. I'm going to go ahead and slow down and retract back and do it again. Okay, so I'm going to go ahead and retract back. Light went out. I'm going to go ahead back again. But now, look that number right there. It changed again. Minus 0.5, minus 5.0487. It was 85 earlier, so it was a difference of 2/10. Earlier I changed a lot. Why? Because I moved too fast and I was at 10x, which is 1000, okay? So, but anyway, so I'm gonna go ahead and retract. That is z-axis on the offset geometry is done for this tool. Retract back. I could go a lot faster backward because I'm going into the positive. And then I go back. Okay, so my bad. I switch to the x-axis and then I go up and I go up and then I need to touch, and then I go back this way, and then x-axis, I get very close, then I have to change this to about 10x, and watch this number right here on the screen. The number on your screen is minus 9.0435, and as soon as we touch the sensor for the x-axis, which is the vertical movement, it's gonna hopefully change to a number. Now it's minus 9.0435, 435. Just remember that number. All right, it changed. Minus 9. It's minus 9.0433. So like an improvement of about only 2/10. I mean. It's really already set, ready to go. Okay, so I'm gonna go ahead and slow down here. Instead of the 10x, we're gonna change it to 1x and retract back. Okay, I'm gonna retract back from the tool, and and see what happens. I'm gonna wait. The lid comes off, and then I'm gonna touch it again. Now it even went a lot more. Minus 9.0424. So it improved quite a lot. So that is basically at a very, very slow rate. The movement of 1/10 would help the sensor to basically, respond accordingly. But if we had it at 10x, which is 1000, that's quite a movement. So always that's what I do. I go to a 1/10 and I get my values better that way. Okay? So I'm gonna go ahead and turn it off now. I'm gonna go a lot faster, go up, and then I'm gonna go out of the way. Now I press back the setter, the tool setter, I press it again. We just finished setting our tool number 1 on the geometry offset. Now the machine knows the tip of that tool, its 0 position is, for the X value, is minus 9.042, and for the Z value is minus 5.0487. Those are the values based on a work shift input that is 5 point something that we already had there. Okay, so you do the same thing for every tool, for all different 10 tools that you have. So I'm going to go ahead and return this home, and then I press home position. My turret is going to go home. It just went home, my position right there. And then I do to tool number 2 like that, number 3, number 4, number 5. I set them all up, and then I'm ready to go. So that completes how you set your tool. It's offset geometry. The good news, this machine has an automatic tool setter. All you have to do is bring the tip of that tool and touch the x-axis and the z-axis, and then the offset for both the x-axis and z-axis will be automatically recorded for you. On the other machine, at least I know the SC150, you have to enter it manually. Okay, get a known value and input it manually. You have to use these keys and enter it. Okay, or you could say major, and you could also incorporate it that way. All right. So the advantage of this machine is the fact that it has a tool setter. So that takes care of the tool setter. How about the other step is work shift input, and then work shift on. We got a switch here. So what I do for that is, let's say if we were, remember all 10 tools, they will touch that setter and they will establish their offset geometry values. Now, one of those 10 has to touch your part, and that will establish the work shift input. Once you know that, at least only one of these tools, not all 10, just one of them, touches your part, that will establish where your work or your part or the piece you're machining. Once you establish that was just one tool, the other 9 tools will know where the part is, or where that piece is. So you don't have to touch for every one of them. You just have to do it for only one of the tools. Now let's go ahead and do the same thing with tool number 1, because we're already right there. And I'm gonna use the face of the jaw as my part. Okay. So what I do right now is nothing, but I go to my handle 100. Okay. And then I'm gonna go ahead and I'm at the Z value, and then my turret is moving, and then my X, and then my Z. So I'm gonna go ahead and just put about, right? Let's see. I'm gonna try to find something that's super flat, and that might be good enough. Okay. So I'm gonna go ahead and I could go a little down. I just want to put a piece of paper there. So as soon as I get close, as soon as I get very close. Alright, so that's the movement of 10,000. I'm going to switch my handle to 10x because I only want to move 1,000 at a time. And I'm gonna pinch my paper there until it can move up on its own. There we go. That is my piece of paper. It's held right there. Now what I could do is I work shift on. I need to turn that guy on. And as soon as I click on that, look, the screen changed. Now it is on a work shift value. What do I do now? I just say, hey, let's go ahead, input the work shift based on that. And when I press on that, the value changes to 6.2003. Oh, 003. Remember, my piece of paper is about close to 3,000 thick, which means that it is a gap of 3,000 thick. So I'm going to take my caliper and measure my piece of paper. It's about 3,000. I'm going to say 3,005/10. Yeah, that's 3,000. So I have to add 3,000 to that so that it will go further in, because that's where my real part is. So it's going to be, I'm going to go ahead and change that to 6.2033. That is, I added 3,000 to it, and I'm going to say input is going to change that number. Input right there, because my piece of paper is 3,000. So I just added 3,000 to that to get me to whatever I needed to be. That is, now the machine knows, all the tools knows, the face of this jaw is the Z0 position. Okay? I'm going to go ahead and retract back. Before I do that, I need to turn off this guy. Before I move my thing, lock this guy, because if you move it, then it's going to change. So I'm going to say, hey, I'm done establishing my work shift position. So you got to turn that off. Make sure that you don't leave that on, because if you do, then it's changing. Because all you need is, yeah, it's not going to change until you press this guy. But somebody might press that guy, and now your thing is changed. Okay, so I'm going to go ahead. My machine is going home. I'm going to say, hey, I want you to go home. My third, it went home. So that basically finishes on how to set up your geometry offset as well as your work shift. So now, do we really know how to use these buttons? Yes, we do. That is tool setter, and that is to establish your work shift, which is your Z0 position. Okay? Now all the tools, as soon as you bring them close over here, their value will be almost at 0. And they will be at 0 as soon as they touch here. With what? With their tool offset. So if I were to use a program right now, and the program would call the tool number, let's say tool number 1 is written as T0101. The first T is tool. The first 2 digits, 01, is the tool number, which is written on the turret. The other 2 digits will be the offset value. Okay? So the other 2 digits are these values right here. Minus 9.0424 and minus 5.0487. So, and that the offset number. See right there, it says offset number 01. So when you call a tool, you don't call T0100. Well, that doesn't have the offset value on it, which means it won't use those numbers. But if I say T0101, now I know it's my tool number 1 as well as using offset, these offset values. Now the machine, as soon as I go to that value, it will show that tool. As soon as it gets close to that face of that jaw, it will read 0. Now I think that finishes the lesson on these. All right, so we just finished setting up tool number 1 with these buttons here and establishing the work shift as well. So we're done with that. The next button that comes is what they call a spindle jog. So this spindle jog, I mean, it's not really that important, but we want to see what it does, okay? So I'm going to go ahead and change my mode to jog, and then I'm going to jog the spindle. So as soon as I press that, look at my spindle. It's jogging at a very controlled rate. Okay. So really this speed right here doesn't matter because I'm at jog. When I selected speed, and it's basically spinning the spindle. Okay. So I'm jogging the spindle, and then I could go over here and also do the same thing. As long as I'm on the manual mode and I press this spindle jog, the spindle will rotate. Okay. All right, so that takes care of that. And, okay, so next is the emergency button. Let's say I will have my machine running at a very high. Well, I'm going to adjust the spindle, but the spindle is running right now. And now all of a sudden, something weird noise I hear. Now my emergency button right here, let's say this door is closed, and all I have to do is basically press this guy, which is my emergency button, and everything shuts down. Look on your screen, there is a flashing light that says EMG, that means the machine is under emergency mode. And not only that, I'm going to show you also these values right here. The pump went all the way to 0. The pressure of the pump went all the way to 0. You can see the indicator. And also the chuck also is shut off. So nothing on this machine basically runs right now. We have to take it out of the emergency mode. Not only that, the machine light is on also, means the machine is under an alarm. So there is so many information that the machine gives you. As soon as you press the emergency button, your screen flashes, your machine light will lit, and also the pressure on the pump went to 0. The chuck went to 0. So those two are shut off. The only way now to bring the machine back is because you intentionally press this guy or the emergency button. All I have to do is press it down and rotate it clockwise. Okay, I rotate it clockwise and I let it go. Now everything, the machine light is off, and I hear some kind of noise in the machine. It clicks and it hums, and everything is normal. And if you really look your pressure, they went back, and this guy is at almost 40, and this guy is almost like 5, and so they came back on. The machine is back again, live and running, and everything is okay. Okay, so now the next buttons we have to use, or at least see them in action, is the feed hold and cycle start. Remember those two, we use them on program, so we have to go to program, and let's look what kind of program we have. We have program 40. We're gonna start that job, and my coolant is on, so I'm gonna go ahead. It's on off. We'll leave it at off. We don't want any water or coolant splashing on us, so we put it on 0. Although there is a M8 which turns on the coolant, it won't come on because we have it off over here. So this overrides that requirement, okay? Now, this guy, we need to remember, we need to get this really, really slow, okay? And that is really slow. Now I'm at the beginning of my program, but remember my mode is on the manual side, and I'm trying to start automatic run. No, I have to switch this guy to edit if I want to make some changes on my program, but I don't. So I have to change this to memory, which means the program is in the memory, it's going to go from the memory, okay? So you switch this to the auto side and put it under mem, okay? Now, when I press start, cycle start, look what is going to happen to our machine. And as soon as I do that, it switched to tool number 8. Hey, well, it's cycle running right now. I want to feed hold. Look, my spindle is still running because I have it on feed hold. So this is the reason we use these two switches. One is to start the program, and the other one is feed hold. The turret was moving, advancing towards my pod, but I said, hey, feed hold, and I stopped it. If I want to continue, I press cycle start again, and it's advancing again, and I can stop it for whatever reason, okay? And it's just basically waiting for me, saying, hey, okay, so what do you want to do next? Maybe I want to kill my machine, stop my machine, whatever I want to do. But I'm going to go ahead and say, hey, no, continue, go ahead, run. And now, for some reason, I changed my mind. No, stop. So the feed hold is nothing, but it would stop the turret from advancing with the tool towards your pod, okay? That's all it does. And now, I guess we just learned how to use the cycle start and feed hold, and those two work on where? On an automatic mode when a program is running, okay? So that. Okay. All right, so we finished these buttons right here. We actually saw them in action. Now we want to deal with those 3 buttons. As long as my switch right here, which is on the manual side, my spindle forward would go ahead and spin the spindle forward, and then my stop button will stop the spindle. My reverse will also reverse the direction of the spindle, okay? So that's pretty much what they are used for, but you have to be on the manual mode. When you're on the automatic mode and you say, hey, forward spindle, it ain't going nowhere, it's not going to rotate. So you have to be on the manual side for your spindle to work, okay? So I guess that takes care of these 3 knobs right here. Well, might as well also do this speed. This guy controls the speed of the spindle. You can see the spindle, I mean, I know they're like pictorially showing like the line here gets wider. It starts with a small white line and then it gets wider and wider. And that's basically your speed. And you can speed, your speed is going like crazy. And right now I'm going to go ahead and turn this guy slow. And so that is forward movement. And I can stop that and I say reverse. On the reverse, the same thing. I can change the speed of the spindle. And it's and look, my load. The indicator of the load also shows like where it's moving. It's like about close to 50 right now. But every time I move a knob, so that was what on the red. Gotta go back, and you can hear the spindle is like making a lot of movement. All right, so. We just finished using all these knobs. Now we have a handle over here, and this handle does nothing but move the turret, okay? It moves the turret depending which axis is selected. We got this switch over here or toggle or knob. Either we place it at X axis when I move this guy it moves the x-axis. But also, we have to be also on the handle. If we're on the jog mode, you can only use these buttons. You cannot use the handle. So you have to be under handle. It could be under 1x, 10x, or 100x. Then, if I'm at 100x, my x-axis is selected. When I go to the negative side, the turret moves down. See that? And then when I change it to z-axis, and I also go to the negative side, my turret moves horizontally, which is the z-axis. So for my handle to work, which will only move, the handle only moves what? It only moves the turret. It moves it like, its corresponding axis. Is it moving it on the x-axis or z-axis? So that's right now, because we have x-axis selected, you can see the turret moving it up and down at a slanted angle. Okay, if I put it to select z-axis, and then it shows moving back and forth. Okay, and my mode is at 100x on the manual side. So only the handle works here, only if it's under the handle. If I go to jog, and I try to use the handle, look at your turret doesn't move. Why? Because it's waiting for me to use either of these four. So if I say jog, and I said, hey, I want you to move on the negative z-axis, it's moving. If I go position here, oh my bad, position here, and look right there, the z-axis is moving. The reason it's moving slow, why? Because I have the feed rate really slow. So if I go about right here, look right there, that is moving because I increase feed rate override. I go a little higher, 100. If I go really slow over here, and then I press, it's moving, but like, look, it's like if I go right here, this guy is gonna move. See, like I'm pressing on it, it's moving really slow. That's like a 10th movement. If I increase this guy, look what digits start to move. The digit that starts to move is, wow, really fast. See that? Yes, that's moving really fast. If I even go further, and I press that, look, look, my turret is moving back and forth, and you could see the movement, okay? And I can move down, and I can move up, okay? So this is what we use the knobs for. So this is kind of like, mechanical movement of the turret is with a handle, in conjunction with selection which axis you want to move, in conjunction with the mode being at either 1x, 10x, or 100x, where the handle is written on, and it only works on these three scales. As those three scales, the handle works at 1x, 10x, 100x, but also we have to make sure we select which axis we want to move. Okay, so I guess that takes first to that, and then what I added with it is, we could go to jog, and we have to use this jogging because there is a word over here written jog, and we can move. Now we don't need to select an axis because this in itself has an axis. This is minus z-axis plus z-axis plus x and minus x. So you don't have to use this guy because this in itself is an axis. Okay, because our switch over here on our knob is switched to jog. Okay, then I have rapid move, which is similar to jog, except it's a lot faster movement. I press this guy, look what it just did. The turret is jumping like crazy. See that? And that is a rapid move or a rapid jog. Okay, and then finally we got jog and rapid jog. That's what we're doing. Rapid jog. It just moves up and down, sideways, a lot faster. You can look over look at your turret up. Down, up, down, up. This is, I'm only pressing them like for a second, and they're moving like quite a lot. Okay, because they're at rapid. Now I'm gonna go to 0, return, and then I press these two, and it's gonna take it home. And this will go fast. Still, it went to 0. So we basically learn how to use all these 1, 2, 3, 4, 5, 6, 7, all these to move what? To move the turret. Only moving in the x-axis or z-axis, or you could jog them in the x-axis or z-axis. You could rapid move them, you could jog them, and you could return to 0, okay? So that is, take care so that, alright, so we just finished learning all these knobs right here. Now we're gonna go ahead on this side. Now, I think I might have, described those, but we're gonna see them in action, see how they work. Okay, now, feed override is, we still have to be let's go to mem, and we're gonna go to program, and let's go to edit and go all the way to the top of the program. At the beginning of the program, I'm gonna put it on mem. This will speed up the automatic mode, okay? It also could override the feed rate. I mean, on the jog, we could also look at it on the jog. We put this on manual jog and with an x-axis. And then when I say, hey, look at this guy right now, position, it's moving. Now if I increase these, look the movement, it's a lot faster. You can see, like that guy is moving like really, really fast. If I put this guy at about 100, and it's moving, but it's not visual to the naked eye. That is movement for your turret moving in the x-axis. Z-axis. And I can press this guy down. It's moving down on the x-axis, but a lot slower. Now, if I press it to about 150%, look what it just did. It just like ran down fast, up fast, down fast, up fast. Okay? All right. Now I'm going to go ahead and put this one back. Rapid override. This is when you're in the automatic mode. So we have to go to program, and we need to switch this to mem. We're at the beginning of our program. Look what we're going to see here. Okay? We're really, really slow. We have our coolant off. Okay? And this is at 100%. And then we're going to say, hey, let's go ahead and start this guy. And as soon as I do that, first you need to go home, because that program G28U0W0 tell the machine, hey, go home first before you do anything. So already it's built into the program, okay? So it's going home. Once it goes home, and then it's going to go back. Now, I just switch the tool. I can look, I'm going to switch over here, rapid override. Look, I mean, it went too fast, right? So we're going to go ahead and feed hold or reset. We're going to go back home again. I'm just trying to show you the rapid override. What does it mean? Let's go ahead and just go home. We're going home. All right. Now I'm going to go really slow, and I'm going to go to man. My bad. Here, and I need to go back to the beginning of the program. Then I'm going to go slow mode. Okay. Now, I'm going to have to add a little more separation, because I don't want my tool coming and colliding here and start doing machining on the face of the tool. So I'm going to put about, I'm going to go ahead and offset. And I'm going to put work. On my work, I'm going to go ahead and put on my z-axis about 3 inches. I just want to be about 3 inches off. Oh, my bad. 3 inches is 0.0. Okay, that is 3 inches input. Look at that value. It just pushed my data by 3 inches away. Okay, so it's going to use that value, and I don't want you to worry about that too much right now. I just want to make sure when I start my program, it doesn't start machining the face of my tool, because that's what we established the 0 is. And the program is, machining on the negative z-axis. All right, so we're going to go back to the program. We're at the beginning of the program. this rapid override is going to start. I'm going to say start. Okay, and it's going, and I'm going to speed like rapid override at 25%. Like it went really fast. Okay, so it better stop about 3 inches away, and we'll do its machining there, and then it's going to go home. Okay, it's going home now because I separated it about 3 inches. I don't want it to go machine on the face, so that Z value that I put 3 inches, it put it back. Now I know my first spot because I was really slow. It's going home. It's going to repeat the cycle because I have, or is it going to kill the cycle because it's not? It's M30. M30 throw it back to the thing. Okay, I'm going to put M99. Wait a minute. So I'm going to change that M30 to M99 on my program, so that way it will become a cycle. So M99, and I'm going to say alter. It just changed that 30 to 99. Okay, and then I'm going to go all the way to the beginning of my program. I'm going to say to mem, and then I will say, hey, let's go ahead and start that all over again. And then I'm going to go to 25%. Look what's going to happen. See that? It just went there. It's going to do that, and it's going to repeat the same cycle over and over, and until I tell the machine to stop when they need to stop. Now I'm going to go ahead and change this one to what? To 100%. Let's do this. Now it's going to go like crazy. Woo, woo. It's just like real quick. Why? Because I changed the rapid override to 100%. So that's what it's going to do. That's how quick it's going to machine the part. But typically I run at 25% because I got nothing else to do. I just want to take my time. But I can put to 100%, and this is what you get. Okay? It is machining and like, whoo, and go back. So that is what we talked about. Rapid override. Okay, so I guess we just finished rapid override and also feed rate override. Now we got this toggle over here, which that one is block the lead. The first one is lock the machine. If I lock the machine, can I start anything? No. I could go back in this program, and I could go to the beginning of the program, and I said, hey, ma'am, and I'm going to slow this guy down, and I'm going to say, hey, can you please go ahead and start running? And hopefully it's not going to run, I would assume. See, it started, but the spindle, yes, it runs, but nothing else runs. The machine is locked. Look, it looks like it's running in terms of the program, but look, the machine is not moving. The turret is not moving anything because it's locked. I cannot move the machine. So you can see the programs, all the blocks, they're moving around. I'm jumping, I'm going through them. But because my machine is locked, it only goes through those different blocks. Those are single blocks of the program. But because the machine is locked, the turret is not moving. Okay, I know the spindle is moving, but so that is how we use machine lock. All right, so we're at the beginning of the program. We're discussing block delete on. So I'm gonna go to mem. I'm at the beginning of the program, and I'm gonna go ahead and say, hey, we need to slow this guy down, and we're gonna say start. It should skip that. Oh. Okay, so we should. It's gonna go because we have a slash in front of it. It's gonna skip that. See that? It skipped the one with the slash without doing any kind of machining, and it's going home now. So that basically, that's how you, if you want to skip a certain block, you put a forward slash in front of it, and you have to make sure the delete block is turned on position. Okay, so this guy, all right. And then we have dry run. You can have that on, and we say, hey, let's go back to the beginning of the program. I'm gonna delete, I'm gonna remove the forward slash here. So delete that. And that is, okay. Okay, so that's at the beginning of the program. It's slow, edit, and then I have to go to mem, and then I have to turn on dry run. What does dry run mean? All right, well, hold on. I'm gonna go ahead and press. I'm gonna go to mem. We have our dry run button turned on, and when I say dry run, I guess is with no coolant. See, when we have the dry run, look, our rapid override, it doesn't work. See that? Which means the machine is running at a very, very slow rate. That's what it's called, I guess, dry run. Because I cannot speed it up, I cannot do anything. Okay, so that's for a dry run. A dry run, you use it to just see what's going on. Okay, so that takes care of the dry run. I'm gonna go ahead and set it off, and then we're gonna go home. And I'm gonna speed it up, go home. Okay, dry run, we just turn it off. Single block, you turn it on. We should be at the beginning of the program for us to use that. Then I go to memory and single block. Every time it moves one block at a time, so you have to press it on and on. I'm in cycle start. You have to continue to press every time it finishes a block, which is basically one horizontal line of the program. You have to press cycle start again to go to the next one. Okay. So here you go, and then here you go, and then here you go. See, like that is where it starts, and then I have to go. Look, now the turret is moving, and then once it finished movement, which is basically going close to your part, is G0, X whatever value, Z whatever value. The turret is going to just stop after it finishes that block. It will just stop, right there. It stops. I have to press cycle again, cycle start to move into the next one. Now we just turn it on the water, and then I have to say G1, press it again. Now it's moving. So I finish also that, like, you know, the cycle start light comes on while it's doing the single block. Once it finishes that single block, it turns off. Look right there, it's on, off. Now it's on, which is basically going home. No, actually machining. Now we turn it off, then to turn off water. Then now, when I say home, now it's going home. So that is what single block movement. All right. And then you have optional stop. You have to put M0 somewhere in your program. And then if I go back, let's say I go about right there, and I said, hey, EOB M0 insert. Okay, so I'm gonna put, my bad, delete that. Okay, now I'm gonna put over here EOB insert. Look, that M0 is right there. It's an optional stop. Okay, it's right here. It's an optional stop. That is M0. We're gonna go to the beginning of our program. We're gonna go edit to mem. Now we have to turn on this optional stop, and then the machine will stop when it goes to that thing. Okay, so I'm gonna go ahead slow. This is still slow, and now it's going home. I'm gonna speed it up a little. There you go. Now when it goes to that M0, it's gonna just stop right there until you do whatever you need to do with the machine, and then you press cycle start again. It won't move forward. See right there at M0, your spindle was running, your turret was moving. Now all of a sudden it stops. Okay, it stops right there. Now let's say, what do I have? Maybe I need to remove some chips, do whatever I needed to do here. Once I'm done, just put it on feed hold. His lid is calm because it's holding on us, and then I have to press cycle start again, and then it's doing its job now. Go back home again. We need to speed it up. Alright, so we're home and we're done with the optional. So there are two over here. One is for a coolant, and then one is program check. So I'm gonna have to close here the manual thing. It's just a toggle. You turn it to manual, and that's for the coolant. The thing is basically speed and water coolant, and then I can turn it off. And if I put it on automatic, then it would use the program and use the code for turning on the coolant from the program, and then it would turn it on. We got M8 is turning on the coolant, so when we're running a program, it would basically use that code to turn on the coolant at the appropriate part of the program step. Okay. And then another one, check, program check, and what I could do is I could go ahead and put this on edit, go to the beginning of the program, okay, and then I'm going to put a mem, and I'm going to turn this guy program check is on, and then I'm going to go ahead and turn off the water and say, let's slow this guy down. It is running. It's checking the program. Okay, so I don't know if this really helps you, because it should have checked the program while it's like, in position. So maybe I should have turned on the dry run. But other than that, my turret is moving. It's advancing towards the port. That's not really dry run. Checking program. I mean, it's basically doing what it needs to do. Okay. Anyway, that is checking the program, and now I reset the machine. I'm gonna go ahead and go back home. I need to speed it up a little bit. Now, I'm gonna turn this guy off. The last one we got left is these two. This is, like I said, if I wanted to select it's an indexing, just to go select the right tool manually. That's what this has to be on the manual side, on the manual mode. Otherwise, you won't do it. Okay. If I go into the automatic and I press, it doesn't work. This doesn't work on the automatic side. It only works when I'm on the manual side, because the manual I'm trying to do something. And then here you go, another third one, which is the stroke release. That's when you exceed your, when you exceed what? When you exceed your zero position. Let's say if I go, this guy I put it to zero position, and I want to go home. I go home, this is the home position right there, because both lights are lit. If I continue to go to the positive side, let's say I go X, and I try to continue to go on the positive side, my machine would shut off. So let me go ahead and just go Z-axis. I'm going to continue until my machine goes into an alarm mode and shuts everything off. My bad, I need to put this guy. Alright, so look right here on the Z-axis, and eventually an alarm is going to come on because my machine cannot exceed. There you go, my machine is shut off. Why? Because I exceeded my Z value zero position. So now if you really look, my machine status right here is lit. Like, you know, my machine is under an alarm mode, and also my hydraulic system also down, shut it off. So everything is shut off with the exception of, you know, the electrical thing coming into the machine. Now, to take it out of that mode, I have to press stroke release N. Okay, and when you press on that, you're going to hear a click. Not only would you hear the click, but also the machine status light goes off. So what I have to do is use the handle, move into the negative position, and as soon as you do that and you release the stroke release, life is back to normal. Everything, the light is off. Your pressure is back again to the right appropriate values. So life is normal and good. And I guess that pretty much finishes the actual, you know, way of, we did the, without turning on the machine, we went over these. Now we turn on the machine and we saw the functionality of every knob over here and what we use it for. And on the next, maybe we're going to go over this, which would be for another time. This completes the hands-on lesson on using all the different knobs on a Nakamura Tome TMC 20.